So let's, while we're here, have a look at the tests for different organic compounds. So how can we distinguish quickly between one class of organic compound and another? So let's have a quick little review over our different types of organic compounds. This will just be a revision here. First we have our alkanes, which are saturated, and they have the same homologous series. Saturated means there are no double bonds throughout. That is the homologous series. The standard formula is CnH2n plus 2. The natural gas, liquid petroleum, these are some examples. And the functional group is the alkyl group. Let's say this is called an alkyl group. Single bonds is the key defining factor. Let's look at alkenes. Alkenes have a double bond, and they've got a formula of CnH2n, and they are unsaturated. That means this can react to have another hydrogen form joined to it. Then you have alkynes, which are also unsaturated. They have a CnH2n minus 2 general formula, and they have a triple bond somewhere in the middle. And you can see that if it's done correctly, there is the number there which indicates where the double bond is. We have alkanols, which have a formula of CnH2n plus 2O, or, the way I prefer it, CnH2n plus 1 OH. Because that OH there is the functional group, that hydroxyl group that's called. That's a hydroxyl. And then we've got our alkanoic acids. The functional group here is called a carbonic acid, and it looks like this. So it's like C double bond O OH. So it looks like an acid, but it's got the extra oxygen in there. And this is the general formula there. The first 4 are water soluble, but after that they become insoluble, and the hydrogen bonding, which would go on, for example, if we had another one of these, would allow for quite strong hydrogen bonding, because there's 2 there for each one, and this gives us quite a high boiling point. So let's have a look at the tests. Now, if we wanted to test for an alkane, we want to see if something's an alkane, we add bromine water to it, and nothing happens. We already know it's an organic compound. There are other ways to tell, the smell, for example. And we add bromine, and nothing happens in the presence of light, or UV light in particular. If it's an alkene, though, and we add bromine, the color of the bromine changes from brown to colorless, even in the dark or light, so either way, rapidly. But if we have an alkyne, and we add bromine water to it, the bromine changes from brown to colorless slowly in light. That's the change there. That's the difference between these two. We have alkanol. So if we got an alkanol, we can burn it. That's one thing you can do with an alkanol. That's what it means here by oxidized. So, fire. You can burn the others too, but alcohols burn, or alkanols burn quite easily. But if we dry it with calcium chloride, and then we add sodium, that should be a solid right there, not that, it's a solid. If we add sodium to an alkanol, we'll end up with this chemical here, there's 2 of them, and hydrogen gas will be formed. If we add sodium to these guys, we will not get hydrogen gas at all. But this one will get hydrogen gas, and we won't get hydrogen gas here. It distinguishes between these two quite effectively. Or we can have an alkanoic acid, where if we add sodium carbonate, carbon dioxide will form. And those are our distinguishing tests. Alright, so if you have any questions, put them in the comments below, and we'll get back to you as soon as we can. Thanks for watching. Bye now.